Welcome to the fascinating world of electrocardiography, or ECG. Whether you're a healthcare professional, a student, or simply someone curious about how the heart works, this guide is designed to demystify the complex process of ECG. Understanding ECG is not just for doctors, it's knowledge that can empower anyone interested in the health sciences. Let's embark on this exciting journey together, breaking down complex cardiac concepts into understandable chunks. Ready? Let's dive into the heartbeat of the matter. ECGs are more than just squiggly lines on a paper. They are the heart's way of communicating its health with us. By the end of this guide, you will not only grasp the basics of how ECG works, but also learn to recognize some common heart rhythms. Imagine being able to look at an ECG chart and understand what it's telling you about someone's heart. That's our goal today. Whether for professional development or personal knowledge, mastering ECG can be incredibly rewarding. Let's keep things light and engaging as we simplify the complexities of cardiac monitoring. Ready to unlock the secrets of the heart? Before diving into the intricacies of ECG, let's start with the basics: heart anatomy. The heart, a muscular organ about the size of a fist, is central to the circulatory system. It's primarily made up of 4 chambers, 2 upper chambers called the atria and 2 lower chambers called the ventricles. Understanding these parts is crucial because each plays a specific role in pumping blood throughout the body. The heart's pumping action is regulated by electrical impulses that trigger heartbeats. These impulses start in a small bundle of cells known as the sinoatrial, or SA node, located in the right atrium. The SA node is often called the heart's natural pacemaker because it sets the rhythm of the pulse. From there, the electrical signal travels through pathways in the heart, ensuring coordinated heartbeats. This electrical journey not only keeps the heart beating, but also forms the basis of the ECG. Each wave you see in an ECG represents a specific part of the heart's electrical cycle. With this foundational knowledge, we can now explore how these electrical impulses are captured in an ECG. An electrocardiogram, or ECG, is a simple test used to gauge the heart's electrical activity. Small electrode patches are attached to the skin of the chest, arms, and legs. These electrodes detect the tiny electrical changes on the skin that arise from the heart muscle's electrophysiologic pattern of depolarizing during each heartbeat. In simpler terms, an ECG translates the heart's electrical movements into lines that can be analyzed on paper or a screen. This translation allows doctors to observe the heart's rhythm, the speed of the heartbeat, and the strength and timing of the electrical impulses passing through the various parts of the heart. These observations are crucial for diagnosing various types of heart conditions. What's particularly fascinating about an ECG is its ability to provide a real-time snapshot of heart activity. It's a vital tool not only in diagnosing disease, but also in monitoring overall heart health. As we delve deeper into reading these results, you'll see how each part of the ECG waveform has a story to tell about the heart. Interpreting ECG waveforms might seem daunting at first, but with a bit of practice, it becomes more accessible. An ECG waveform consists of several different parts: the P wave, the QRS complex, and the T wave. Each component reflects a different phase of the heart's electrical cycle, from the atrial contraction to the final repolarization of the ventricles. The first step in ECG interpretation is identifying the P wave, which indicates atrial depolarization. Following the P wave is the QRS complex, marking the rapid depolarization of the right and left ventricles. This is usually the most noticeable part of the ECG. Lastly, the T wave represents ventricular repolarization, the recovery phase before the next heartbeat. Understanding these components is key to recognizing normal and abnormal heart rhythms. For instance, a regular, consistent pattern suggests a normal rhythm, while variations might indicate issues like arrhythmias. This basic understanding is crucial, whether you're a healthcare student or a practitioner looking to refresh your knowledge. Congratulations on taking your first steps into the world of ECG. By now, you should have a basic understanding of heart anatomy, how an ECG functions, and the fundamental aspects of reading an ECG waveform. Remember, mastery comes with practice and continuous learning. Don't hesitate to revisit these concepts and explore more in-depth resources. Empowering yourself with the knowledge of ECG can be a valuable skill, whether in professional healthcare settings or just for personal interest. It provides insights into one of the most important organs of the body, the heart. Keep exploring, keep learning, and most importantly, stay curious about the wonders of human anatomy and physiology. With the basics under your belt, you're now on your way to becoming proficient in understanding and using ECGs. Here's to your health and your continued journey in the fascinating world of heart rhythms.